Okay, here's the formative for the probability review for Mr. Humphreys. You need your calculator for this. You need to be able to reduce fractions. Okay, here we go. Andre and his dad have been fishing for 2 hours. In that time, they have caught 9 bluegills and one yellow perch. The next time Andre gets a bite, what kind of fish do you think it will be? Explain your reasoning. Okay, so he has 9 bluegills and 1 yellow perch. Okay, so what do you think he's going to get his next time? Probably a bluegill. Why? Because he caught more bluegills already. So obviously the bluegills are easier to catch. Lynn is interested in how many of her classmates watch her favorite TV show. So she starts asking around at lunch. She gets the following response: 4 yes and 10 no. She asks one more random classmate. Do you think they will say yes or no? Explain your reasoning. So far she's got 4 yeses and 4 no's. So what do you think? Probably no, because more people have already responded no. The chances are that the next person will probably say no. An engineer, let's go up. An engineer tests the strength of new material by seeing how much weight it can hold before breaking. The last tests were as follows: 1,200 pounds, 1,400 pounds, 1,300 pounds, 1,500 pounds, 950 pounds, 1,600 pounds, 1,300 pounds. And I noticed that this is the only one that does not have over 1,000 pounds. Do you think that this material will be able to hold more than 1,000 pounds on the next test? Explain your reasoning. Yes. Why do you think that? Because all of them have held over 1,000 pounds except one. I mean, it's close, but for the most part, yes. A company tests a new product to make sure it will last for more than a year. Product 1 had 950 out of 1,000 test items last for more than a year. So what is the probability that product 1 will last for more than a year? Write it as a fraction, decimal, and percent. Okay, make sure you reduce your fraction, round to the 100th, use commas and no spaces when typing your answer. So it should look like this. You should have a fraction, comma, a decimal to the 100th, and a percent in your answer. Now to get the answer, we have to look at it. We have product 1 had 950 out of 1,000. Well, that fraction is going to be 950 out of 1,000. Okay? Now to reduce the fraction, we could cut that off right like that, and that would be 95 over 100. And now I could divide these both by 5. That's going to be 20, and this is going to be 19/20ths. So to write that in the box, type it in the box, you're going to go 19/20ths, comma. Now to find the percent of that, okay, all you have to do to find the decimal is to divide your fraction from top to bottom. So 19 divided by 20. So 19 divided by 20 is going to give me 0.95. To turn this decimal into a fraction, all you do is times the decimal by 100 to make to turn the decimal into a percent, you just multiply that decimal by 100. So 95 times 100 is going to be 95%. All right, next one. A company tests a new product to make sure it'll last for more than a year. Product 2 had 150 out of 200 items last for more than a year. Remember, product 1 was at 95%. What's the probability that product 2 will last for more than a year? Using a decimal, fraction, decimal, and a percent. Well, the fraction is going to be 150 out of 200. Reduce it. That turns to 15 out of 20. Divide by 5 on both sides. That will give me 3/4. So my fraction is going to be 3/4. My decimal is 3 divided by 4, which will give me 0.75. And to times this by 100 to make a percent would be 75%. And that's what you need to have in that box. So 75 and 95. Okay, so watch the video. All right, thanks. Now, same question. Okay, this is the same question we just talked about. It says the company tests 2 new products to make sure they will last for more than a year. Product 1 had 950 out of 1,000. Product 2 had 150 out of 200. And I remember, if I go back and I look, I remember that this one was 95% for product 1. That lasted more than a year. And this one was 75%. That lasted more than a year. So if you had to choose one of these 2 products to use for more than a year, which one is most likely to last? 95% for product 1. So in here you type product 1. Okay, so now we're just going to write this as a fraction, a decimal, and a percent. Okay, so the fraction would be 1/2. You still type in the fraction. The decimal for 1/2 is you just divide it from top to bottom, which would give me 0.5, or you could write 0.50 to make it to the 100th spot. And then times that by 100 will give us 50%. And you already know that. You already know that 1/2 is 0.5 and it's also 50%. Half of something is 50% of something. You already know that. All right, 1/3. That's 1 divided by 3. I'm going to divide that, and that is going, it says round to the nearest 100th. So that's going to be 0.3333. It goes on. So round it to the nearest 100th, which is 2 places after the decimal, 0.33, because this 3 cannot round that 3. Times that by 100 would give me 33%. So the answer here is going to be 1/3, comma, 0.33, comma, and 33%. Okay. Here we go. Let's write this as a decimal, or fraction, decimal, and percent. So 2/5, and that means 2 divided by 5, which should give me 0.2 divided by 5 is 0.4. You could put 0.40. Either way, it could be 0.4 or 0.40. Times it by 100 gives me 40%. So this is going to be 2/5, comma, 0.40, comma, 40%. Here we go. Same thing. 0.6. Oh, that's already a decimal. So it's already a decimal. We have to turn it into a fraction. Well, that is in the tenths column. Okay, so that means 6/10. There's a fraction. But can I reduce that fraction? Yes, I could divide these both by 2, and that will equal 3/5. Now to make it into a decimal, well, it's already a decimal. So that's going to be 0.60 or 0.6 times that by 100, which would be 60%. So this answer here would be 3/5, comma, 0.60, comma, 60%. Okay. Let's go to the next one. 33%, 40%, 60. I already did those. Okay. You got the hang of it pretty quick, and you didn't. Write the following as a fraction, decimal, and a percent. Okay, well this one is already a decimal. So I got the decimal part down, but that means 3/10. So that is going to be 3/10. Okay, that's easy enough. That can't be reduced. The decimal is 0.30 times it by 100. Go. Okay, and that would be 30%. So the answer to this one, 3/10, comma, 0.30, comma, 30%. Okay, now these numbers all look familiar. We just did them. 1/2, 1/3, 2/5, 0.6, and 0.3. We just did that one, okay? So it says put these numbers in order from least to greatest and use a comma to separate and no spaces. Well, I already did these and I can kind of think about them already, and I'm just going to turn them all into percents. If I need to go back, I'll look, okay? This 1/2 was, if I remember correctly, was 50%. 1/3 was 33%. 2/5 was 40%. 0.6 was 60%. And 0.3 was 30%. Look right there. See, and I know that because I can think about. So put them in order from least to greatest, but I'm going to put the original numbers in order. What was my smallest number? 30%, so I'll write 0.3, the original number. The next one was 33%, so I'll write 1/3, the original. That one's done. 40%, 2/5. Done with that. 50%, 1/2. And 60% was 0.6. That's all you do there. All right. Now this one talks about likelihood. And what you need to know about likelihood is there are several different amounts. And if you look at number 15, you could see that there's impossible, unlikely, as equally likely, likely, or certain. Impossible always has a 0% chance of occurring. Equally always has a 50% chance of occurring. Certain means no matter what, it has a 100% chance of occurring. So unlikely is anything between above 0 and before 50%, and likely is anything above 50% but not 100%. So anything in between 0 and 50 is unlikely. Anything above 50% is likely. Okay? So let's look at this. I'm going to keep that there. The likelihood that Hans can make a free throw is 60%. Okay? The likelihood he makes a 3-point shot is 0.345. Which event is more likely, him making a free throw or a 3-point shot? Well, 60%, and I could turn this decimal into a percent. All I have to do is times it by 100, which gives me 34.5%. So which one's more likely? Because I'm going to compare the percents. 34.5% or 60%? Well, 60% is more likely. So a free throw is more likely for Han. Okay, so this one says, different events have the following likelihoods. Convert them to percents and then list them from least to greatest. Oh, okay, let's convert these to percents. This is easy enough. Well, this is already 60%. 8 out of 10 is the same as 8 out of 10. If I divide that, I get 0.8. If I times that by 100, I get 80%. And you probably already know that. If you take a test and you get 8 out of 10, you know that's an 80%. 0.37, that's a decimal. All I have to do is times it by 100, and that will give me 37%. This one's already done. And 5/6, all I have to do is 5 divided by 6, which gives me 0.83 repeat. I times that by 100. That will give me 83 repeat percent. So this is 83 repeat percent. So now let's put those in order from least to greatest. So the least one here is 20%, comma. Then the next one is 37 right here. So I'm going to put 0.37. The next one is 60%, and that's the original 60%, comma. Then 8 out of 10, so I write 8 out of 10, comma. And then I'm going to write 5/6. And that's the answer on that one. Okay, so here we go. What is the likelihood that you will win a grand prize in a raffle if you purchase 2 out of 100? Well, it's not certain. It's not impossible. This is not a 50% chance. And it's not a very good chance, 2 out of 100, that you're going to win. So that one would be unlikely. Sorry about that. What's the probability that you will wait less than 10 minutes before ordering at a fast food restaurant? That's a pretty good chance. Usually at a fast food restaurant, you don't wait longer than 10 minutes. Is it impossible? No. Is it certain? No. Is it a 50% chance? Nah, it's not unlikely. You have a pretty good chance. It's pretty likely that you will order in 10 minutes at a fast food restaurant. What is the probability that you'll get an even number when you roll a standard number cube? Now, a standard number cube has a 1, a 2, a 3, a 4, a 5, and a 6. And out of those, 2, 4, and 6 are even. That's half of them. Half of them is equally likely as not. That's a 50% chance. So there's a 50% chance that you'll roll an even number. What's the likelihood that a 4-year-old child is over 6 feet tall? I'm going to go, it's not certain. It's not likely. It's not 50% chance. And it's not even unlikely. This right here is impossible. Unless you're in the Guinness Books of World Records, which I don't even think that there's ever been a kid that's 4 years old that's 6 feet tall. That's impossible. You could argue with me about it for the percent. Whoops. But I'm going with impossible. What's the probability that no one in your class will be late to class next week? So no one will be late. Is it certain that no one will be late? No. Is it likely that no one will be late? Yeah, it's pretty likely. Is there an exact 50% chance? Late or not late? Yeah, it could be that too. Is it unlikely that no one will be late? No, I bet you there's a chance somebody will be late. Is it impossible? No. I think, pretty much everybody's on time, but what's the chance that no one in your class will be late? No one? That one's tough. I'm going to go, it's unlikely that no one. I'm going to go back to this. I'm going to say this one is unlikely that no one will be late. There's usually somebody late. It's unlikely that no one will be late. All right, the next baby born at the hospital will be a boy. It's not impossible. It's not certain. Not unlikely or likely. It's equal. There's a 50% chance because you can get your child, it could be a boy born, it could be a male or female. 50% chance. What's the probability it will snow in Mentor on July 1st? Is it certain? No. Is it likely? No, it's not likely. It's not a 50% chance. Is it unlikely that it will snow on July 1st? Or is it impossible? I'm going to go with impossible. I don't think it's going to snow on July 1st. It's impossible. Is it impossible? I don't know. It's unlikely. It's unlikely. Impossible or unlikely. I mean, I don't know. It was pretty cold last summer. That's up for debate. All right, so that's the go formative. Global warming, who knows? What's the probability that the sun will set today before 11 p.m.? It's certain. The sun will set, unless our Earth explodes. Rolling a standard number cube will result in a 5. Is it certainly 100% chance it's going to be a 5? No. Is it impossible? No. Is it 50% chance it will be a 5? No. There's only 1 out of 6 chance, which is a 16% chance. Is it 16? I got to double check my calculator on that. Yeah, about a 16% chance, which is unlikely. That's not more than 50% chance. What are the chances of rolling a standard number cube will result in 15? Wait a minute. A standard number cube only has a sample space of 1, 2, 3, 4, 5, 6. So pretty much impossible. Because you can't get you can't get 15 if there's only 1 through 6. What's the chances of rolling a standard number cube to result in an even number? It's not impossible. Not certain. I already did it up here. There's 2, 4, 6, 3 out of 6 chance, which is a 50% chance. 50% equally likely as not. I think we already did that one over here. I think we did that one. Huh. Yeah. For this, hopefully that helped you understand it a little bit better. Hopefully you started getting